이번 동영상은 보대 플롯 테크닉인데 사실은 이 2006년도 지금부터 한 20년 전이죠. 그때 만들어 놓은 자료인데 사실은 뭐 인트로덕션 투 보대 플롯 테크닉 이 정도로 이해하시면 될 거죠. 왜냐면 제가 하다 말았기 때문에. Introduction of frequency response design method. The popularity of frequency response methods with practicing engineers has remained high over the years despite development of alternate design methods such as root locus, state space, and optimal control. The primary reason for the popularity of frequency response design is that it provides good design in the face of uncertainty in the plant model. For example, systems with poor known or changing high frequency resonances can have their feedback compensation tempered to alleviate the effects of these uncertainties. Currently, this tempering is carried out more easily using frequency response method rather than any other method. frequency response method, frequency response 디자인의 그 장점에 대해서 얘기하고 있죠. For a complex system with more than one input or output, frequency response methods have been extended called H-infinity design to aid in design and especially to establish measures of sensitivity to plant uncertainties. Another advantage of using frequency response is to ease with experimental information can be used for design purpose. Raw measurement of the output amplitude and the phase of a plant undergoing sinusoidal input are sufficient to design suitable feedback control. No intermediate processing of the data to arrive at the system model, poles and zeros or system matrices is required. The wide availability of computers has rendered this advantage less important now than it was years ago. However, for relatively simple systems, frequency response is often still the most cost-effective design method. A disadvantage of the method is that the underlying theory is rather complicated and requires a rather broad knowledge of complex variables. However, the methodology of design is easy, and the insights by running the theory are well worth the struggle. Frequency response. We will describe how a system responds to sinusoidal input called the system's frequency response. In addition, we will delineate how this response can be obtained from a knowledge of its 4 and 0 locations. To introduce the idea, consider a system described by like this, where the input ut is a sine wave, an amplitude of u0, that is ut equal u0 sine omega t, which has the Laplace transform us equal u0 omega divided by s square plus omega square. The Laplace transform of the output is ys gs u or u0 omega divided by s square plus omega square. A partial fraction of expansion of the preceding horizontal equation with the form where a1, a2, an are the poles of gs, where alpha 0 would be found by placing the partial fraction expansions and alpha 0 star is the complex conjugate of alpha 0. 뭐 여기까지 하다가 말았거든요. 하여간 그 frequency response 메소드에 대한 장점을 기술을 했고 뭐 깊은 이론을 하다가 너무 버거워서 여기서 멈춘 것 같습니다. 이 정도로 해서 끝내겠습니다. 감사합니다.